Okay, so this video is about completing the square. So what do we mean by that? So we can turn a quadratic expression or quadratic equation into a form where we have a perfect square plus or minus some add-on. And when we turn it into this form, then we can read easy where the vertex of a curve is. Yeah, so the vertex down here, that would be either the lowest point or the highest point. So either the minimum or the maximum of a curve where it turns. Yeah, so but for that we need to turn it into this form where we have a perfect square and some add-on. Yeah. Okay, so let's look how we would get that. We have a, let's see, y equals, we have a quadratic function here, and so the first thing we do is we divide this by 2. Yeah, so or we take 1/2 of 8, and that gives us 4. Then we take this 4 and we square it, and that gives us 16. Okay, so, and then I rewrite the top. So I write x squared plus 8x. And then I take this 16 and I add it on, and then at the same time I take it away again. So that way we're not actually changing anything about the equation. It is just a tool that we can use to find the perfect square. But we are not changing the equation because as we add it on, we take it away straight away. And then I have the rest, plus 20, okay? So I've rewritten my equation now, and but I haven't changed anything. I've just rewritten it. But now I can bracket this off, and from this now I can form the perfect square. Okay, so this is now my perfect square. So that would be x plus 1/2 of 8, all squared. I can now calculate the add-on, so that would be minus 16 plus 20, which is plus 4. From this now I can read the vertex. So the vertex, the x value we get from here. So that's the x value, but we have to change the sign. So it would actually be minus 4, comma. And the y value I get from here. Here we don't have to change the sign, so I just say 4. Okay, we're going to look at another equation which is slightly different. So that would be 2x squared minus 12x plus 8. Okay, so here we have a 2 in the front, so we need to deal with that one first. So what I do, I take the 2 out. I take the 2 out, and then I divide everything by 2. So if I take the 2 out, is x squared. So again, I go 12 divided by 2 minus 6x, and 8 divided by 2 plus 4. So I've taken the 2 outside of the bracket because in order to use the formula that we've just used, we can't have a number in front of the x squared. But I carry that 2 with me now the whole time. So I can make a big bracket here. Okay, so again, then we have a look again. So I take 1/2 of this number, which is 3. And then I square it, which gives me 9. So first 1/2, then I square it, and that gives me 9. And this is what I add on and take away. So again, x squared minus 6x, and now I add on 9 and I take away 9. And then I have the rest, plus 4. So let me change the color maybe. Make it a bit clearer. Okay, so plus 9 minus 9. So that is that added on and taken away. And then the rest was plus 8. No, sorry, plus 4. Plus 4 because we had divided by 2. And I close the bracket. Okay, so I keep that 2 with me now, just carry it with me. Big bracket. And now I can put brackets around here, which will then give me my perfect square. So that would be x minus 3 all squared. So that would be that perfect square, yeah? So from the x squared minus 6x plus 9, that'll give me the perfect square. And now I can look at the rest. Minus 9 plus 4 is minus 5. Okay, so now I'm not done yet. So I need to multiply that 2 with a 5. So I take away the square brackets essentially. So that's what I'll do. Yeah, I take away the square brackets. So I won't multiply out this. I just leave it like that. The 2 stays in front of this bracket, but then I multiply out the 2 times minus 5, so which gives me minus 10. And now I'm done. Again, I can read the vertex from it. So this would be the x and this would be the y. So the x gives me a 3 and the y gives me a minus 10. Remember, for the x we have to change the sign. And that 2 tells me, that number in front of here tells me how narrow or how wide a curve is.